Between a chain grate boiler and a fluidized bed boiler, which one has the advantage? If you are interested in this topic, then this video is made specifically for you. Hello everyone, it's great to see you again in today's video on the DIVI channel. Today we will compare chain grate boilers and fluidized bed boilers. To compare these two boiler technologies, we will first review the main components of each system. Please note that I will be comparing a DIVI fluidized bed boiler with a chain grate boiler designed and manufactured in China for the Vietnamese market. Looking at the comparison table beside me, you can probably see that if both systems are properly invested in, the number of equipment items is basically similar. Many customers import complete production lines from China, where the boiler system comes together with the machinery. Because of that, they often do not pay much attention to the detailed boiler configuration. This is a common issue that leads to higher steam production costs, increased maintenance risks, and production interruptions. By the end of this video, you will clearly understand why this happens. Now let's go into a detailed analysis so you can clearly see the differences between these two boiler technologies. Let's start with the first topic, investment cost. If a chain grate boiler is invested in properly with a complete system configuration, the investment cost can be quite similar to a fluidized bed boiler. However, many Chinese boiler suppliers provide only a very basic boiler configuration, one that simply burns common fuels available worldwide and produces steam. They usually do not focus on the cheapest locally available fuel. As a result, this type of basic configuration has a much lower investment cost compared to a fully optimized fluidized bed boiler designed around local fuel conditions. The second point is installation space. Chain grate boilers are designed more compactly for easier international transportation, so they generally require slightly less installation space than fluidized bed boilers. The third point is fuel compatibility. Fluidized bed boilers can use small-sized fuels such as rice husk, wood chips, sawdust, coal fines, cashew shell waste, coffee husks. The fuel moisture content can even reach up to 50%. Meanwhile, chain grate boilers typically use fuels such as larger-sized coal, wood pellets, rice husk pellets, wood chips, and similar fuels. With fresh fuels that have high moisture content, chain grate boilers usually cannot operate at full capacity or maintain environmental compliance. Let's take a closer look at why chain grate boilers struggle with high moisture fuels. Normally, a chain grate boiler has 3 combustion zones. Zone 1 is near the fuel inlet. This is where the fuel starts to ignite. Zone 2 is located between the front arch and rear arch. This is the intense combustion zone. Zone 3 is the burnout and ash discharge zone. However, with wet fuel, the moisture must first be reduced to a point where the fuel can ignite by itself before combustion can actually begin. As a result, Zone 1 is no longer purely an ignition zone. It becomes a drying zone with only partial ignition. This continuous evaporation absorbs a huge amount of heat, significantly reducing the combustion temperature. As a result, more CO gas is generated due to incomplete combustion, and the combustion efficiency also decreases. In a fluidized bed boiler, fuel is supplied only in the amount required by the steam demand, so the instant moisture evaporation is much lower. This helps maintain a consistently high combustion core temperature. In addition, the combustion process inside a fluidized bed boiler creates a large suspended fireball inside the furnace. This helps stabilize the furnace temperature even when using high moisture fuels. The inability to efficiently burn high moisture fuel is one of the biggest disadvantages of chain grate boilers. Next, let's compare the fuel feeding systems. Fluidized bed boilers use a fully automatic fuel feeding system. Fuel is supplied through conveyors and screw feeders based on the boiler pressure signal. It automatically supplies fuel based on pressure signals in the boiler. If the factory consumes more steam, the conveyors and screw feeders run faster to supply more fuel into the furnace. If the steam demand decreases, the conveyors and screw feeders slow down to reduce fuel supply. This means that the fuel is always supplied in just enough to meet the steam demand. In a chain grate boiler, fuel feeding is also automatic, but it works by adjusting the speed of the moving grate. Normally, fuel is loaded into a hopper above the grate, and the moving chain underneath drags the fuel into the furnace. When the grate moves faster, more fuel enters the furnace. When it moves slower, less fuel is supplied. When the boiler reaches the target pressure, the grate stops moving. With this feeding method, when steam demand is low, backfire can occur along the fuel path, creating a serious fire hazard. Furthermore, with this type of fuel feeding, there will always be a large amount of fuel on the chain guide. Therefore, if the fuel continues to burn, the pressure will continue to rise uncontrollably. This is especially true when burning coal with a high rate of combustion, and this is also a weakness of chain grate boilers. Now let's compare combustion efficiency inside the furnace. In a fluidized bed boiler, part of the combustion chamber is located below the steam generating tubes. The design prioritizes optimal combustion before heat transfer takes place. It works almost like a smelting furnace, creating very intense combustion and allowing the fuel to burn more completely. Chain grate boilers also use a separated combustion chamber with furnace arches to intensify combustion. This also helps improve combustion efficiency. In a fluidized bed boiler, fuel particles are suspended and continuously mixed with air at an adjustable ratio. And this mixing capability will result in a smooth combustion process and very high combustion efficiency. In a chain grate boiler, the fuel is spread into a fixed thick layer on the grate surface and remains mostly stationary during combustion. The fuel burns layer by layer. Inside the chain grate boiler, the fuel bed is divided into different combustion zones: the ignition zone, the intense combustion zone, and the burnout zone. Since the fuel stays fixed on the grate, the mixing between fuel and oxygen is not ideal. Therefore, the combustion efficiency is generally lower than that of a fluidized bed boiler. Next, let's compare environmental emissions. There are two major aspects we need to compare here: dust emissions and toxic gases. Regarding dust emissions, if the cyclone separator, bag filter system, and wet scrubber are properly designed, dust is not a major concern for either boiler type. As for gaseous emissions, the main concern is carbon monoxide, or CO gas. The first factor is fuel moisture. The second factor is combustion temperature. The third factor is the oxygen to fuel ratio. The lower the fuel moisture, the lower the CO generation. The combustion core temperature should remain above 800 degrees Celsius to minimize CO formation. Both fluidized bed boilers and chain grate boilers can achieve this condition. If combustion lacks oxygen, CO formation increases significantly. If there is too much oxygen, the furnace temperature drops, which also increases CO formation. Fluidized bed boilers provide much better mixing between oxygen and fuel, while fuel is supplied precisely according to demand. In chain grate boilers, a large amount of fuel always remains fixed on the grate surface inside the furnace. As a result, the fuel-to-oxygen ratio is often not optimized. If combustion lacks oxygen, CO formation increases significantly. If there is too much oxygen, the furnace temperature drops, which also increases CO formation. So in terms of environmental performance, fluidized bed boilers currently have an advantage over chain grate boilers. Next, let's compare steam production costs. The cost of steam production consists of two basic costs as follows. Fuel costs are one factor, followed by electricity, water, chemicals, and operating labor. Because fluidized bed boilers have higher combustion efficiency, their fuel consumption per ton of steam is typically 5% to 10% lower than chain grate boilers when using fuel with moisture below 30%. For high moisture fuels such as fresh wood chips, chain grate boilers operate inefficiently, so it is difficult to make an accurate fuel consumption comparison. In addition, the fuels commonly used for fluidized bed boilers are usually cheaper than those used for chain grate boilers. As a result, the fuel cost to produce 1 ton of steam with a fluidized bed boiler is typically 15% to 30% lower than with a chain grate boiler, depending on the region in Vietnam. As for electricity, water, chemicals, and operating labor, the costs are generally similar for both boiler types. Therefore, the total steam production cost of a fluidized bed boiler is usually at least 15% to 30% lower than that of a chain grate boiler. Now let's move to maintenance and servicing. Chain grate boilers have two major weaknesses. The first is the chain grate itself. It is a moving mechanical system operating continuously under high temperatures, and it can weigh up to 10 tons. Whenever this component fails, the boiler must be shut down, cooled down, disassembled, repaired or replaced, and then reinstalled. Even in the best case, repairs take about 3 days for small systems and 7 to 10 days or even longer for larger systems. The second weakness is the furnace arch built above the grate. This arch creates a reflective combustion angle that helps the fuel ignite and burn completely. But if the arch becomes damaged or collapses, the boiler usually has to stop operating for reconstruction. Rebuilding the furnace arch can take 10 to 15 days or even longer. This creates a very high risk of production interruption. Fluidized bed boilers do not suffer from these issues. Even if part of the fluidized bed grate is damaged, the boiler can often continue operating until the next scheduled shutdown for maintenance. Also, the furnace walls are vertical and flat, making them much less likely to crack or collapse compared to chain grate furnace arches. In nearly 20 years in this industry, I have only seen customers switch from chain grate boilers to fluidized bed boilers, never the other way around. Next, let's compare equipment lifespan. When properly designed, manufactured to standard, operated with correct water treatment, and regularly blowdown maintained, both boiler types can normally last 10, 15, or even more than 20 years. However, the lifespan of the chain grate mechanism itself is relatively short. Because it is a continuously moving component operating under high temperatures, its lifespan is shorter than other boiler parts. In terms of capacity range, both technologies can be designed and manufactured from 2 tons up to 100 tons of steam capacity. Those are the 10 comparison points between chain grate boilers and fluidized bed boilers. I have summarized all comparison results in the table beside me. My recommendation is that chain grate boilers are suitable for factories with stable steam demand and consistent dry fuels such as pellets or high-quality coal. Fluidized bed boilers are more suitable for factories using fresh biomass fuels with high moisture content and requiring flexible fuel adjustment. If you found this video useful, please leave a comment and share your thoughts below. And don't forget to subscribe to the channel for more upcoming videos. See you again in the next videos. Thank you very much.